Hi all. Today we are going to understand the function of CT and PT in the substation. So this is the scheme drawing for a 132 kV substation where this is one PT. This is the symbol of PT. This represents the primary winding. This represents the secondary winding of the PT. And this is the symbol of the city. In case of city, the primary winding is the main wear and the secondary winding is shown like this is city. Now ctpt are always connected, I mean rated in the phase voltage. So this is a 132 kV substation, so phase voltage is 132 by root 3. So that is how it is defined. When we define a PT, we define it like that: 132 by root 3 kV by 110 by root 3, 110 volt by root 3 by 110 by root 3. So this is a PT 132 kV by 110 volt. The secondary is 110 volt, which is the control voltage. Now why there are two? Because there are two core in this PT. One is called the metering core and another is called protection core. The metering core goes for to the meter, which will show the voltage, and protection core will go to some relay. See, this is the metering code. This is going to the demand controller. It will also it is going to the VSS, is a voltmeter selector switch, and then it is going to, and it is going to the voltmeter through the VSS uh, voltage selector switch. It is going to the voltmeter, and also it is going to the demand controller. Demand controller will calculate the demand, and see here it is the protection core from PT2, right? So this is the PT2 protection circuit. It is going to this protection core. Here it is going. So there are MICOM 141, MICOM P442, and auxiliary relay. This relay will need this voltage to calculate all these protection parameters. So this is the purpose why PT are used in a substation. One is metering, another is protection. So now how it is defined? The core one, the class is a zero point 0.2 and 50 VA. 50 VA is the burden. Burden means this is the energy it will consume for itself. And the class zero point 0.2 is the error. It says that total error, phase error, or the ratio error would be 0.2%, not more than that. And the core 2 is a protection core. This is how a protection core is defined: 3P. 3P means the error should not be more than 3%, even in the fault condition. And the VA is 50 VA, even for the core 2. VA, as I said, it means the energy consumed by that PT. Similarly, this is the city. City has one, 2, 3 core. This is a three core city: core 1, core 2, core 3. Sorry, there was some issue. So again, the core 1 is the metering core, core 2 is the protection core, and core 3 is also a protection core. It is called the differential core, PS plus city, PS plus core. It used for differential protection. Now core 1, uh, the current rating is 300 to 600 by 1. Core 2 current rating is 300 to 600 by 1. Secondary is 1 ampere, and Core 3 again 300 by 600, 300 to 600 by 1. There are tappings available. You can use 300 ampere setting, or you can use the 600 ampere setting. The secondary is 1 ampere. Sometimes it is always also 5 ampere available, but 1 ampere is better because I square I loss is much lesser. So it is I square R loss. If I use it 5 ampere, then it will be 5 square R. So that is why 1 ampere is always a better choice, smart choice. Now again, the class is point 0.2. Point 0.2 means error should be less than 0.2%. 15 VA means energy consumption in this core is 15 VA, limited to 15 VA. 5P20, this is called ALF, accuracy limit factor for any protection class CT, means 20 times current if flows through the primary, then also the error should not be more than, or error would be less than 5%. Again, the VA rating is 15 VA, and similarly for not similarly, this PS class city is very different. We need to calculate this VK value. Here the VK value is 250 volt and RCT is 5 ohm. RCT is the resistance in the city. Okay. And I mag is equal to 30 milliampere. This is a very standard value. I mag means magnetization current required for the city is 30 milliampere. This VK value we need to calculate, and RCT we need to restrict this RCT within 5 ohm. Generally, that is what we try to do. Where it is used mostly in case of differential protections. So 21 is a line differential. Maybe this is why is used here. Sometimes, for example, transformer differential is also there. Both sides of the transformer differential cities are used for differential protection. So this is the purpose of this city. uh, and other protection cities means these cities, the core 2 is used for other protection like 50 50 n 51 51 n. These protections are calculated and activated based on the rating of this city, and this city core is used for the metering purpose. This is going to this meter, this ammeter, through this ammeter selector switch, and also for demand control calculation, how much energy is consumed, and all this. I think this is all you need to know about what is CT, what is PT, and why it is required in a substation. If you want more videos like this, you want to clear your doubts regarding electrical engineering design, please put it into the comment section. I will create video on that. Thank you.